Hello everyone. So kule video discuss question paper laga grade 12 maths paper 2 from November 2011. Again solve equation A based with trigonometry, and then this time select question 9, right? So lapha ku question 9.1 bathi if tan A is equals to 3 over the square root of 40 and A is an angle between 0 and 90 degrees, determine the values of the following with the aid of a sketch and without a use of a calculator. Leave your answers in SAT form if necessary. They want us to determine the values, the value of cos A and the value of sine 180 plus A, right? So now drawing a sketch, we see ukuthi tan A is 3 over the square root of 40 and A is between 0 and 90 degrees. So lokho kusitshela ukuthi A is an angle between 0 and 90 degrees. So now we will draw our triangle with first quadrant because the angle is an acute angle, right? So we have angle A here, and then we know ukuthi from SOHCAHTOA tan is opposite over adjacent. Here we are given ukuthi tan of A is 3 over 40, so the opposite side will be 3, the adjacent side will be the square root of 40, right? So now they want us to calculate the value of cos A. Remember that cos A is the adjacent side divided by the hypotenuse. We do know that the adjacent side is the square root of 40, but then we don't know the value of the hypotenuse. So first things first, we need to calculate the value of the hypotenuse. We know ukuthi it will be the square root of 40, squared plus 3 squared, right? So this will be, from your calculator, it will be equals to 7. The square root of 40 squared plus 3 squared will be 7, right? So now our hypotenuse is 7, and then from SOHCAHTOA we see ukuthi cos is adjacent divided by the hypotenuse. The adjacent side being the square root of 40 and the hypotenuse being 7, right? And then we go to 9.1.2, and then this is where we apply the reduction formula, right? But is sine, we want the value of sine 180 degrees plus A. Remember from our cast diagram, in the first quadrant all the trigonometric ratios are positive, in the second quadrant only sine is positive, third quadrant only tan, and fourth is only cos that is positive. And then now we want to evaluate the sine of 180 degrees plus an angle A. 180 degrees plus an angle will throw us in the third quadrant where only tan will be positive. Now from this diagram we see that sine will be negative in this quadrant here. So applying a reduction formula here, will have negative sine A, right? And then from our diagram there we know from our diagram in SOHCAHTOA, we know what sine is opposite over hypotenuse, right? The opposite side is 3 and then the hypotenuse is 7, so minus sine A will be minus 3 over 7. Okay, moving on to the next question. 9.2. Okay, let us create space for 9.2 here. Right, so 9.2, but without the use of a calculator, Determine the value of the following expression: cos of 100 degrees divided by sine of minus 10 times tan squared 120. Right? So now again we'll apply reduction formula somehow using the cast diagram. Here it's sine, and then here is tan, here it's cos, right? And then so now because I see in the denominator I have sine of minus 10 degrees, somehow I want to change this to be to have the same trigonometric ratio as in the denominator, because it is possible, if you look at cos 100, it can be written as a cofunction of sine. Now reducing this, we will say cos 100 degrees is the same as saying cos 90 degrees plus 10 degrees, right? Divided by sine of minus 10 degrees is minus sine 10 degrees, and then multiply by tan of 120 can be written as 180 degrees minus 60 degrees. This is all squared. And then, so from our cast diagram, 90 plus 10 will throw us to second quadrant. And then to second quadrant, cos is negative. But then because we are having 90 plus, this will change to sine, because sine and cos are the cofunctions. Right? Now here we'll have sine minus sine 10, right, divided by minus sine 10 degrees. And then here again, tan of 180 minus 60 will throw us to the second quadrant, because 180 degrees minus 60 is an angle in the second quadrant. And then in the second quadrant, tan will be negative. So there we will have tan of 60 degrees, all to the power squared, right? And then this and that will cancel. We will have 1 multiplied by, now here we have to apply special angles, right? We know when applying special angles, we need to think of these triangles here. We know sine 30 is 1 over 2, right? And cos 60 is 1 over 2. And then here we have the square root of 3, right? Whenever you're using special angles, think about this triangle here. And then now we know tan 60 will therefore be the square root of 3 divided by 1. The square root of 3 divided by 1, but then we have minus there, all squared. Now this will be equals to 3, and then you have simplified this expression. Okay, moving on to the next question, 9.3. So 9.3, we are given this diagram. They are saying P and M are points on a circle with the origin as the center. Q and R are the x-intercepts of the circle. They want us to write down the numeric value of sine ROP. Sine ROP is this angle here, this one here. ROP is that angle. So now, to make things simple, I'll create my own triangle, right? So I'll create my own triangle that will enable me to calculate sine ROP. So now, from our sketch, we know we have O somewhere here, and then we have okay, O will be here, and then here will be our hypotenuse, and then because the coordinates of P, the coordinates of P is 4 and 3, so I'll drop a perpendicular line. I'll drop a line perpendicular to the x-axis from P. So if I draw a straight line from point P to the x-axis, I will sort of have this triangle here. So here I will have my point P, which is 4 and 3, right? And then dropping it to the x-axis, we'll have that point. So now from point P, from the coordinates of P, we see the x is 4 and y is 3. So it means the length of this side will be 4 and the length of that side will be 3. So now we want sine ROP. So here we have R, and then we want the sine of this angle ROP, right? Excuse me. So we know what is sine is opposite over hypotenuse, but then we don't know here, we don't know the value of the hypotenuse. So we need to calculate the hypotenuse here by saying it is the square root of 4 squared plus 3 squared, which will give us 5. So now here we will have 5. Therefore sine ROP will be equals to the opposite side, which is 3, divided by the hypotenuse, which is 5. So that is sine ROP. And then going to 9.3.2, they want us to calculate the size of QOP. They want us to calculate the size of QOP. Okay, so looking at the diagram, QOP is this angle here, right? And then we can calculate the angle ROP because we have the trigonometric ratio already, and then after that we'll use the fact that angles in a straight line sum up to 180 degrees. So from 9.3.1, ROP will be equals to sine inverse of 3 over 5. This is equals to, from our calculator, it's equals to 36.87 degrees. 36.87 degrees, right? Now QOP will be equals to 180 degrees minus 36.87 degrees, which will give us 143.13, 143.13, 143.13 degrees. So that is the size of angle QOP. And then question 9.3.3, they want us to calculate the value of A if POM is an obtuse angle and POM is equals to 115 degrees. So now what we need to do here is, because we know the value of ROP, the value of the angle ROP, and then we also know the value of the angle POM, we need to calculate the value of the angle ROM, right? So we need to calculate the value of the angle ROM. Let me copy this question. So calculating the value of the angle ROM, we will say, okay, ROM the angle ROM will be equals to 150 degrees minus the angle ROP, which is 36.87 degrees, right? So the angle ROM will be 115 minus 36.87. It will be 78.13 degrees. Now we will have that this triangle will have to drop a perpendicular line to the x-axis and have a triangle. So let me sort of draw a sketch of that triangle. It will look like this. So here we will have O and our 78.13 degrees, and then here we will have M, right? So looking at the coordinates of M, A, the x coordinate is A, which is what we want to calculate. So it means the length of this side will be A, the length of this side will be B. Now we are interested in the length of A, right? So because A is adjacent to this angle, we need to calculate the hypotenuse, and then after that we'll use the trigonometric ratio cos of 78.13 degrees, which will be the adjacent side A divided by the hypotenuse. So from question 9.3.1, we've calculated the hypotenuse to be 5. Remember that the OP and OM represent the radius of the circle, and then we know what the values of the radius are equal. So OM and OP are equal, right? So OM will be 5 units because it is the radius of the circle, right? So now cos of 78.13 will be A over 5. This implies that the value of A will be 5 times cos of 78.13 degrees, which will give us from our calculator 5 times cos of 78.13 is equals to 1.03 units. 1.03 units. And then we are done with question 9. Okay, from my view, I think this was a fairly simple question. If you still having some difficulties, feel free to ask me there on WhatsApp so that I can explain la ungazwisisi khona. Yeah.